I'm Chris Price, and today I'm going to be talking about machine learning in JavaScript. So that's what ML stands for, if that's news. I'm going to talk about what it is, what it can do, how it works, and I guess based on our experience, share maybe whether you should be thinking of using it. So hands up, who's heard of TensorFlow before? Cool, all right. Don't have to explain that one. But just in case, TensorFlow is a machine learning framework not traditionally associated with JavaScript, created by Google, and it powers quite a lot of the very cool research you'll have seen in the world of AI. Google, about a year ago, I think, started work on TensorFlow.js. So that's bringing TensorFlow to the browser. That lets you run pre-trained models, so models such as MobileNet, which we'll come back to, models such as PoseNet, which let you kind of do what the Connect could do, so take a picture and pull out the skeleton from that picture. A whole bunch of others, your own, if you've got your own models you want to push down to the client. But kind of uniquely, and the focus of lots of the rest of this talk, you're able to train new models. So this is definitely not product placement. This just happens to be the first mug I found in our office. And so you can see this is a visualization. It's got 1,000 different dots. Don't count too closely. There's only 998. But each of those dots represents one of the categories, which is one of the outputs of MobileNet. And so MobileNet has been fed this image, and it's been asked which category of the data it was trained on does that image most represent. And you can see it's a coffee mug. But also, I guess it's a little bit unsure. It could be a bucket, a cup, an oil filter, a water jug, or a measuring cup. This is a different image. If you know what this is, it's a Lumetric display. The model was not trained on it being a Lumetric display, so it's given it its best guess. So it thinks it's a digital clock, which is probably how you guys would have described it if I'd made you. Finally, this is an iPad, and yeah, it doesn't know what an iPad is. It does know what an iPod is, though, so you can kind of see that. And it can see the similarity there, but it's such a terrible picture. My fault again. It just thinks it's an oscilloscope. The most interesting thing, terrible choice of shirt for this, is it can also do it in real time. So this has just been fed the webcam, and if I maybe tip it back so you can see my face, it generally spots me as a cowboy hat. I've had a lot worse out of it. Cool. So if you want to see that demo, it'll be on our booth afterwards. So why is a good reason? Like, why does any of this exist? Why have they bothered doing this? Well, to paraphrase someone who has shared the FinJS stage, why not? JS is everywhere. Let's get it out in the hands of, let's kind of democratize machine learning. There is a whole heap of JavaScript developers out there. If AI is going to take over the world, web developers are going to have to get their hands on it. There's also an interesting privacy angle. If you're running machine learning in the browser, then you don't have to worry about it being like sharing your data up in the cloud. You can keep it all local, and it helps with some of the privacy concerns. How does it do it? I'm unfortunately not going to get into that in 10 minutes. But suffice to say, machine learning is incredibly numerically compute expensive. In essence, it's using WebGL to compile down those complex mathematical operations into WebGL shaders, which are then ultimately run on your GPU through WebGL. But I guess I tried to sell you at the start on the fact that it allows you to train models. And you might be asking yourself, hang on, models take hours to train. If we have a browser-based app and we ask our users to sit there quietly for 2 hours or 3 hours or 4 hours while it trains up a model, they're not going to be very happy. So what can we do about it? First off, let's quickly talk about training. So this, if you're familiar with machine learning training, is a representative kind of flowchart of a training in progress. I personally, because I'm a JavaScript developer, prefer thinking about it like this. So maybe it's just me, but I find it a lot easier to think about it like that. So how can we make training work? If we are going to be doing training, we want to make use of training, how do we do it in the browser? Well, there's the technique called transfer learning. And transfer learning allows you to capitalize on a pre-trained model and then reuse the vast majority of that model in a new network that's able to have novel features. So in this case, this is an amazing picture of MobileNet, and it's trying to highlight that whilst MobileNet was trained to take a bitmap as an input and output one of 1,000 different categories, that took it hours, and that's hours on very specialist hardware running in the cloud. What we can do, though, is we can slice the vast majority of MobileNet. We can keep the vast majority of it, but we can slice off the classification layer at the end, and we can add our own custom network to the end. Now, that custom network's very small when compared to the rest of the network. That's a good thing. The way the math kind of works out, because we've only got about 1 to 5% of the network, that's going to train in seconds, not hours, which is useful, and users will deal with that, I think. So I want to show you a demo of transfer learning, but before I do, I want to give you some context. So hopefully you're familiar with pit trading. It's a thing that's kind of died off. That's probably for the better, but here's a hilarious video if you're not. So now you're all familiar with pit trading. You'll be experts and you'll know a couple of hand gestures from pit trading. So one interesting gesture in pit trading is, I'm going to take that off the screen. I'm getting distracted by that. All right. So one of the gestures in pit trading is if you're trying to buy, you'll make this kind of a movement. And if you're trying to sell, you'll make that kind of a movement. Now, let's pretend we've gone back to the 80s, but we do still have machine learning in JavaScript and fast browsers and all the rest of it. And we don't fancy standing on the sidelines of this and dealing with angry traders. So instead, let's train up a model. So we're going to use that transfer learning technique that we saw before, and we're going to train it up to recognize my crazy gestures. Hopefully, it's all good. So what we're doing here is we're giving it lots of sample images that are representative of the different gestures, or the 2 different gestures. And the reason for giving a bit of variation in them is when I panic, when I have to do this for real, I want it to be able to spot what I'm actually trying to do. Oh, and again, so I think this is the last iteration. There we go. Right, there we go. Now we've got a training montage going on. But you can see it hasn't locked the browser up, I guess is an interesting point of that. So at the top, it's showing its confidence. We're forcing it to make a decision. So it can only say it's a long trade or it's a short trade. It can't say, I don't know, which makes the problem a bit easier. But so that was a short trade for sell, and that was a long trade for buy. Right, now that we've got that, let's try it for real. Let's make some fake money. So this is a time series. It's going, I want short, go down, go on, do a Tesla, come on. Okay, right, we're going to buy. I'm doing all right. This is the best I've done, so it can. Oh, and it's going to crash at the end. Oh, okay, so I've lost only an eighth of, not an eighth, 8/10 of my money. That's not bad for a day's trading. But you know what? I think Chuck could do better. So you just need to stand there. And, oh, hang on, sorry, important bit.
Is that not authorized?
That's it, yeah. No one's going to listen to you. Got it? There we go. All right, then. I forgot my clicker, so I'm going to have to do some gestures to get it going.
Buy high, sell low, right?
Yep, that's the... All right, so I got on the high scoreboard, so let's quickly get that on for people to beat instantly. And right, so we're going to go into the training. So you want to match that gesture. That's it. And keep going, yeah. And you want a little bit of movement in there just in case it's different.
Really excited.
Yeah.
Yeah, okay.
That's it. Maybe you want to do the jumping around like those guys would do. Cool.
Here we go.
All right.
It's happening.
Got it. All right, okay,
Now
training montage. That's it.
It's important to do that, right?
Yeah.
Okay.
Okay, so let's have a quick check, see if it's picking up the right thing. Short, got it. Long, got it. Brilliant. Right, let's give it a go. All right, so it's going to start in 3. Yep, there you go. You're on. So cell, it's a strong, short.
Sticking with it.
Yeah.
Sticking with it.
It's
Sticking
just
with
good.
it. Here we go.
Yeah.
No. Just a quick second.
Here we go. You got it.
I think I'm doing well.
Yeah, I think you might have chosen a. Wow, you better not beat me. Oh, there you go, pro.
Close. I brought it in tight.
There you go. All right, so if anyone fancies a go at that, it's going to be on our booth as well. Yeah, if you make any money, it's mine. So that was the demo. And quickly, just round out with our experience. So our experience of building this was for kind of the tuck shop in our office. And it's that little kiosk that you can kind of see being used in the corner. And the idea is it can recognize the images from the tuck shop and let you pay for them. Now, the good news is it works. Hopefully that demo also showed it. And it's able to achieve kind of 95% accuracy, which is good enough to keep people using it. I guess the bad, which is probably the most interesting bit and the bit I didn't get told when I heard about TensorFlow.js, it has incredibly rough edges. If you are, and this is stuff they're working on, I don't mean to kind of have a go at them. What they're doing is very cool. But if you're trying to use it and really do training, it's like going back to the dark days of web browsers and jumping between different browsers and feeling the real pain. Different devices behave very differently, and that's basically down to WebGL. And the ugly, and I'm definitely not referring to our interns, the hardest bit of machine learning is getting good training data. It's got nothing to do with how complex the algorithms are, really. TensorFlow.js has made that really easy. It's just getting that training data that's tricky. So to summarize, machine learning is ever more accessible. Go away and play with it. But collecting training data is still incredibly hard. And device support is incredibly limited. But thank you.